Welcome to Fire and Forget, building microservices for the IoT using message-based systems. A little bit of bookkeeping before we jump into it. I want to talk about our agenda. So we're going to be discussing some IoT issues that we're facing. Then I'm going to stop and I'm going to talk about the X platform, and then I'm going to try to marry these two together. I'm going to say why the X platform is such a good solution for addressing your IoT issues. So let's jump into it. The IoT challenges. In some of the stuff that I've been working with, I've seen a lot of different issues on the IoT side, and they all fall into one of these 6 categories, right? The first is compatibility and longevity. And what that means is that when you're releasing things to the wild, when you lose control over your environment, i.e. when you're deploying things to phones, when you're putting things in cars, you're going to end up having to support things long after you've deprecated them. In fact, you're going to have to support them long after you've decommissioned them, right? I actually still know people that have a StarTAC flip phone, right? So that's a good example of having to support things that nobody else is using anymore. Another problem is that we address is standards, right? Or the fact that there's a lack of standards. There's no real guidance on how to produce messages and transmit information in the wild. Some people are doing it in XML. Some people are using JSON. Some people are doing it in binary because, why not? There's no real guidance in that. Another issue that we see is that it's very difficult for traditional systems to do intelligent analysis and actions. And this is due to a lot of different reasons. One of the primary reasons is because a lot of traditional systems are built off of doing things in minutes, seconds, and days, where the IoT world really works in microseconds and in milliseconds. Another real problem that we've seen is that legacy systems aren't really used to working with unstructured data. They are only able to work with structured data, and that becomes a problem when you suddenly start dealing with data that changes and flows with new versions. Another real big problem that you see is the horizontal evolution, and what that means is that as you're using one technology, another technology becomes available, and you have to try to make them complement each other. A good example of this is the NFC, of near field communication, right? And this is the stuff that you use with Apple Pay, or that you're tracking as you're walking through CVS or Duane Reade, and it says, hey, look to your right, you're out of coffee because your smart cabinet told me, and here's a sale, this particular coffee's on sale, right? One of the largest issues that people are hitting when they're working in the IoT industry is scalability and latency. And that's one of the primary purposes for this talk. So I'm sort of just going to skip over that one. And then lastly, there's security and privacy. And if you've been paying attention to the news nowadays, we know that security and privacy are big touch points. And that's why I put a star on it. This is such a big touch point that it's another hour-long conversation. So I'm not going to discuss it now, but I did throw up a slide so that you guys are aware that it's on our radar. So some of the industry statistics and projections that we've seen is that Gartner says there's about 8 billion devices connected devices in 2017, and they're expecting that to grow into 26 billion connected devices by 2020. Now, if each of these devices sent one message a day, in 2017, we'd have to be able to process upwards of 90,000 messages per second. And in 2020, we would have to process upwards of 300,000 messages a second. That's just a lot of messages that you have to deal with. Cisco is estimating that a portion of the internet traffic being generated by non-humans, right, by PC devices, is going to rise to just under 70% by 2019. And of that traffic, location is 70% part of that, right? So it's not just the information that we're transmitting, but how we're capturing the information that's intelligent, that's important. And another nice metric is they're talking about that by 2020, we're expecting to be transmitting 600 zettabytes of information across the internet per year. In 2014 or 2015, MLB transmitted half a petabyte for the World Series alone. So those numbers aren't surprising, but that's just a massive amount of data that you have to walk through. One of the examples that we're going to be talking about, or one of the examples that we're using, is what we're going to expect when we see a smart car. Right? And so what smart cars are doing is they're actually taking telemetry messages, or taking information about how fast they're going, where they are, etc., telemetry, and they're marshaling that up, and they're sending it up to the closest node to them. And that closest node to them figures out where the closest traffic light to them is, and it routes it to that traffic light, to that smart traffic light nonetheless, and that smart video camera nonetheless. And it also figures out that it needs to forward that up to higher nodes that are responsible for higher capabilities of analysis, right? So you're marshaling up the message, you're sending it to a node. That node is routing it to your traffic light, and as well as sending it to additional clouds above you, nodes above you. And then that traffic light receives that information, has to process it, and turns around and sends that back out over the wire with some kind of response. And then that sort of makes its way right back down the network into the car. Now, what we've learned by looking at this example is that there's a new way of operating, and that's called fog computing. Most of you are probably aware of what's called edge computing, where you try to push your computation as far to the edge of the network as possible. But that's not what we found is evolving. What is evolving is this fog computing, where you have nodes at the far end of the network, but they're communicating with additional nodes within the network that'll all be communicating with each other, as well as with the original cloud service provider. And another thing that we learned is if we look at these two cars going side by side right next to each other, traveling at 60 or 70 miles an hour, well, that means that latency matters. That means that we need to make sure we're processing things as fast as we possibly can. And a good example of latency matters is, let's say I have my smart card traveling in Phoenix, Arizona, and I've got an office in New York City, and I've also got an office in San Francisco. So if my car is trying to send telemetry information and get a response back, it'll marshal that up and it can send it straight to New York City in 63 milliseconds. Whereas instead, if it could have sent it to San Francisco, it would have been 22 milliseconds. So that means you have to be actually very aware of how you're sending your data, as well as the distances involved. And so once we suddenly realize that routing matters, we realize that data itself, or transmission of data itself, has a cost, and that it's expensive. And expensive is really broken down into two things. Number one, it's got a monetary cost, and that talks about, these things, maybe they're going over a Wi-Fi network, or maybe they're going over a cell network. And at a cell network, we know that there's about 100 times more expensive than going over a Wi-Fi network because of the latency, but also because of your cell plan. That cell plan could be you have unlimited 5G sitting in San Francisco, but you may, another customer may be using 1 gig 3G sitting in, somewhere in Mexico, right? So those plans are expensive, and those latency costs are expensive. And once you introduce cost into your data, you're suddenly introduced intelligent actors being able to detect connectivity and then change the messages that they're sending based on that connectivity. So you'll be sending a reduced footprint when you're on mobile and doing data dumps when you're on Wi-Fi. And hopefully you'll be able to communicate over on Wi-Fi all the time, but you can't count on that. And once you've got intelligent actors, you've now got strategy evolutions. And once you've got strategy evolutions, you've got version management. And this goes right back to the thing that we were talking about, where you have to support multiple versions long after they may have been decommissioned. And once we're talking about the smart cars, and smart cars are being fed into smart cameras, and smart cameras are feeding smart traffic lights, we also suddenly realize that we're talking about smart cities, which comes down to the fact that we're now talking about smart emergency services, where your police, your fire engines, and your EMTs are all built into your smart city. That means that we have to handle not just the cars, but all of this information at very, very high scale. And because they're emergency services, we cannot suffer downtime. A good story that I like to tell is one of my friends that used to work at Motorola would end up saying, our client's pretty upset with us because we're bringing down emergency services communications for 8 minutes. Really? Well, who's the client? Australia. It's like, really? Australia's going away for 8 minutes? No emergency services are going to be available for 8 minutes? That's a scary thing. So we can't suffer that kind of downtime, not in the IoT world. So those are some of the issues that we've seen in solving some IoT problems out in the wild. Certainly there are a lot more. At this point, I'm going to pivot and I'm going to start talking about what the X platform is. So the X platform is a memory-oriented platform for building multi-agent transactional Java-based enterprise applications. And that's a big statement. I'm sort of jealous of my boss who was able to say it with such seriousness and gravitas that people look at that and they shake their heads and say, yeah, that makes sense. And unfortunately, I'm not one of those guys. So instead of trying to explain that statement, what I'm going to show you what it is how with pictures, right? So the X platform is made up of 6 primary things. The first thing is that we're a message-driven platform, right? One, you get a whole bunch of really good benefits once you become a message-driven platform, but I'm only going to talk about the first 3. The first one is we get a smart routing. We're not just able to specify who we're sending a message to, but we're also specify what kind of message we're sending. I'm going to talk about smart routing in detail a little bit more. But we also provide exactly once processing. And what we do, and as part of that, is we guarantee that your message is going to make it to its destination, and it's only going to happen once. If in the event of a failure, in the event of a reboot, in the event of anything of the sort, you're not going to have to worry about duplicates. You're only going to worry about your guarantee that that message will have processed once. Another thing that we provide you is the ability to fire and forget. Once you start working in the messaging world, you get very lost in the weeds very, very quickly, right? Like building messaging systems, are we using TCP? Are we using different systems? Or are we setting up channels, topics, and queues? What happens if more than one person is subscribing to those channel topics and queues? It becomes very complicated very fast. So we sort of abstract that away, and we're able to just let you say, I'm going to send a message, and we take care of all those details. And the third large thing that we provide when we talk about message-driven systems is the fact that we provide you the business logic is inside the message handlers. We don't like a lot of abstraction layers. We don't have a lot of layers of indirection. We let you pepper that message handler wherever you want within your code so that you can handle it as best suited for your particular code. Another thing to talk about is that we're stateful. And when we mean stateful, I mean that we're dealing with each of our state is in a plain old Java object. We're keeping it as you're used to working with it. You don't have to translate between database tables or CSV. We provide you with Java objects that you're able to use. And now a lot of people end up saying we don't like to keep state in memory because what happens with the inevitable failure? What happens if you have process failure? What happens if the system crashes? What happens if, et cetera, et cetera, et cetera? And one of the things that we've done is we've made the system highly available. That means that if you have a primary node go away, your backup node is going to be able to pick up and continue running. The fact that we've made this system highly available means that we have effectively made memory durable. That means that you're able to write your POJOs to memory with the same confidence that you were able to write them to disk, but you're handling it much, much faster. Now, if you haven't noticed by the picture and also by the title of the thing is, we expose using a microservices approach or a multi-agent approach. And what that means is we want you to pay attention to doing one job and doing one job really well. Now, it's actually a lot harder to do that than you would expect. Right. One of the reasons that it's more difficult to do that is there's a lot of infrastructure that you need. You need to be able to monitor the system of your individual processes. You need to monitor the systems of the overall ecosystem. You need to be able to have a high-speed logger. You need to be able to have good message serialization. There's a lot of different things that goes into building a microservice, and the X platform provides you with all of that infrastructure out of the box, so that you really do only have to worry about building your specific application. The other thing is that we provide you all of this stuff while being ultra performant, right? We don't really give up. We don't compromise on performance when working in this mode. How performant? Well, a lot of our Wall Street clients are dealing with tens of thousands or hundreds of thousands of messages a second, and we're doing it in tens of microseconds. That's while running in high availability mode. Right? And then the last thing is we're horizontal scalability. And this ties right back into the fact that we're message driven in routing, because we obtain that horizontal scalability by doing the smart routing. And this is such an important point that I'm dedicating an entire slide to it. So our messaging provides you transparent routing to the partition that you have. So that means that, for example, I said we have to support versions long after we've decommissioned them, and we have to support new versions that are up and running, right? Those new versions can be configured directly into your system. But on top of that, we're using content-based routing. Because we can see what's happening inside your particular message, we can not only deal with things on a version basis, but we can even more intelligently route that message into the specific instance that it needs to be delivered to. In addition to that, our primary and our backup, the way that we maintain this high availability, they are not using the same communication protocol that you are, right? So that's what we do that so that we're not polluting the communication channel. We're using pipeline replication in order to communicate. And lastly, we try to keep all state in memory, right? We stripe out the state by partition, and that ties in with the intelligent routing, where you're routing appropriate messages to the appropriate partition, and that state is then updated, and that's private to that individual instance, and therefore there's no contention. So you don't have to worry about locking or worry about somebody else owning the same state and have to coordinate with them. Your state is individually yours. So hopefully this statement makes more sense now, that the X platform is a memory-oriented platform for building multi-agent transactional Java-based enterprise applications. The only additional caveat that I'd throw onto it is the fact that we're very, very performance-centric. Now, whenever I'm presenting this particular slide, one of the first questions that comes in is, how are we providing high availability? How are we getting you exactly once? So let's talk about that a little bit, right? All of our applications, when we run it with a primary and a backup, right? And we sitting on top of an asynchronous guaranteed messaging fabric. So once a message comes in, we use that intelligent routing methodology to figure out who we're going to route it to. And then we pass that message to this application logic. Now, this is your code. This is the stuff that you write. You do one thing and you do it well. And this is the stuff that is the domain logic. We can't help you with that, right? So once your code finishes making that change, we then copy over the change in state. We pass that to what's called the ODS, the object data store. And that object data store is then responsible for copying it into your journal for storage, as well as replicating that to our backup, right? And that's happening concurrently in the background. Once the backup has confirmed that it has copied over that change in state to itself, it will then acknowledge it. And once the primary one receives that acknowledgement, it'll then acknowledge the entire message and send it out. The fact that we're only copying over the changes in state from 3 to 3 in the backup is very important, because it means that we're not duplicating the processing on the backup. We're not having to deal with a split brain situation. We're only copying the changes in state, and the backup will then apply it. So you can see if there's a failure in any one particular point of these points, the backup will be able to pick up the communications and know exactly what the primary did before it dropped off. Out of the people in general see this slide and begin questioning, well, looks like it's going to be very difficult. How do we deal with concurrency in this situation? And the fact is, we take exactly once concurrency out. We provide you this exactly once atomic processing in a single threaded fashion. Concurrency is completely taken away, and that's not something that you're going to have to worry about. Now, I keep talking about state, so I want to sort of drive this point home a little bit more. When people in general write their applications, what they're usually doing is they're referencing, hundreds of thousands or millions of records from a database. They do some kind of processing on it, and then they throw it all away. We're asking you to keep this information in memory so that you can do your intelligent analysis on the transactions that are already there. You don't have to go to disk, and you don't have to go to the database in order to receive these transactions. You are already holding it in memory. So people say, well, are you keeping the backup in the backup state as well? And the answer is absolutely, right? As you know, we're copying over that replicated. We're replicating all the changes in state with the delta of applications, and then that's being added into the application, to the backup application. Now, people say, well, you're telling us to do one thing and do one thing well. What happens if I want to do additional types of processing? What happens if I want to apply machine learning to it? Or what happens if I have multiple steps that need to take account? Well, it turns out that we do provide you a communication ability for multiple different microservices, and that this is not going to add a lot of latency to your system. We're able to get things in and out using the latest hardware within a few microseconds from a communication perspective only, right? Then you have to add on top of that your processing time. But for a well-written microservice, this is a very doable setup. And because I keep talking about state, I like to talk about some of the memory numbers. If you are talking about a mechanical disk seek, right, we're talking about 10 milliseconds in time. And if you're talking about a data center read, it's 500 microseconds. And that's if you're hopefully in the same data center, right? If you're working off a remote data center from New York to London or New York to Chicago, you've got, your 14.1 or your milliseconds on top of that actual query. And then going to main memory is about 100 nanoseconds. Now, most of our clients fall into this squarely into this NUMA node and L3 cache area, and some of our clients fall into this L1 and L2 cache. Now, I was explaining this to a non-technical person relatively recently, and they're saying, I don't understand what the difference is. Well, the difference is of 1 nanosecond, or of nanoseconds to milliseconds, is along the lines of saying seconds to days, So by stopping doing database reads, you're going to disk, you're literally going from something of 9 to 10 days into a response time of 1 second. That is a really big speed up. So I wanted to walk us through a good example. This is one of the POCs that we built for one of our clients, and I've had to change the names and the names of the processes and the names of the systems to abstract it. But what this system was is it's a credit card processing engine. Now each of these boxes are like the credit card master, for example, it is running in both a primary and a backup mode. In addition to being to running different separate instances. And the fact that we're able to run separate instances means that each of these application groups are scaled by different metrics. Think about the benefits of that versus using traditional architectures. Traditional architectures, you would end up receiving the request and pass it up to the credit card master. And the credit card master would then query an individual database, do some work on it, and slap its results into a table, where the merchant master would then query that database, do some work on it, and slap its results to a different table, and then pass the same thing to the credit card holder, so on and so forth, where basically people are at that point doing the best that they can with the information that's provided to them. Whereas if each separate application is scaled out by a different metric, right? You're specifically built to be using that information. So you have a much better advantage as far as speed and filtering out unnecessary information on what you're going to be doing. And also, by being able to scale these things out, the credit card master, for example, may end up having 5 different stripes, and the merchant master may end up having 20 different stripes, right? So you're able to scale these things out as appropriate and as necessary. And also, now that I'm mentioning the different stripes, if we talk about content-based routing, what a lot of people end up doing is they pass that individual message to multiple different stripes, and they let all of the stripes sort of figure out if that message was meant for them. But we're not doing that. Because we're looking at the contents of your message, we're delivering the message only to the stripe that is relevant for that particular message, so that it can begin processing. Now, because we support the one-to-many messaging system, what that means is that one message can be delivered to more than a single application. We are able to parallelize this quite a bit. Whereas before, when the message went from the request to the credit card master, to the merchant master, to the credit card holder, and then they made some kind of yay or nay decision on it, and it would go back to the original sender, the latency involved there is the sum of each of those boxes. Whereas if you're parallelizing it here, the latency involved is the max of all of those services, which is a very, very good increase in speed. Something else to notice is, because we provide this content-based routing, and because we support, this is all message-based stuff, and because we support additional topics of things on the fly, you can tack things on later. And this means that you didn't have to think about how to design your entire system 5 to 10 years ago. You didn't have to sit down and figure out how to architect the whole thing long before you've built the whole thing. You can add things on as they become available, or as a new business opportunity becomes available, or as you want to test things. This is something that's very, very common with our Wall Street guys, where they're doing algorithmic trading and they want to test out their individual strategy. Well, they can deploy it to production and they can spin it up for a single product, or they can spin it up for a group of products. And you can sort of do this if you end up dealing on a client basis where you have 10 or 20 or 50 million clients. You can build it to where you're going to spin up 5 clients or 10 clients or 10% of your clientele. Not only can you spin things up, you can do incremental release and testing. And you can spin things down. You can phase them out if they're nearing their end of life. So this is a very, very powerful way for growing out your system without having to have designed your system in its entirety from the beginning. Now, something else that I like to add to that previous slide, I just sort of ran out of room, is that it's very difficult for us to walk into a client and say, well, doing things in the traditional architecture is incorrect or slow, and therefore throw all your systems away and rebuild everything in our methodology. And that's just not a viable possibility, right? So we, out of the box, support the ability to read and write inbound and outbound stuff from traditional architectures. Be that from a database, be that from a CSV file or a batch processing system, or whatever it is, we can communicate with these traditional architectures. So let's look at what it it's like to develop an application or an X application in a nutshell, right? I've mentioned on several occasions that we can see what your messages look like, and we can see what your state looks like. And the reason for that is that we define your messages in an XML language, and this is called the ADM, Application Data Modeling Language, right? And we also define your state in that application language. Our build process then takes that XML and generates the POJOs, right? And then those POJOs are passed into you via these event handlers, right? So this is an annotation-based approach, which means you're able to pepper these methods anywhere you want in your particular code, and you're receiving things in a POJO-based methodology, right? You have access to your entire state repository in a POJO-based methodology, and you can access all of your code just as you would in a POJO state methodology. This is Java. You can use hash maps, lists, vectors, strings, string builders, string buffers, all of that stuff, hash tables, all of that stuff out of the box as you want. But we also provide you with the ability to use a zero garbage framework that we provide. Now, if you remember this picture where I ended up saying routing matters, it's important that you're able to figure out where your states live, in relation to your data centers, in relation to the people that you're working. This is all very well and good for application designers that, don't realize that people move around. They go on vacations. They actually move cities. They take day trips. They take road trips. They jump on airplanes. And we need the ability to move where your state lives from New York to San Francisco, for example, or New York to Dallas, or Dallas to San Francisco. And in one of our upcoming releases, this is exactly what we provide you. It's called sticky partitioning, and we're going to allow you to migrate state in its entirety from its primary and backup system to a different data center, to a different instance. And that instance can be, running in the same data center or in a different data center. This is going to allow you to migrate your entire data centers, providing you with the ability to do no downtime. In addition to our other methodology of providing no downtime, this gives you another option of providing no downtimes if you have to do massive migrations. But this also allows you to do small migrations for individual users, for individual pieces of information that need to be passed over. Like I promised, I'm going to talk very quickly. Security is on our platform, is on our horizon, I'm sorry, we've put a lot of thought into it. As you can see, we've got encryption and access control lists. All of this stuff is peppered throughout our offering. This, however, gets into a much deeper conversation, and so I'm just going to show you this particular slide and then move to the next one. In addition to the sticky states, we provide a zero downtime upgrade by what's calling a rolling upgrade. And what that means is that you're able, if you want to do an upgrade, what we do is you update your new version. You knock down your backup as shown in box number 1. You then rebuild your backup, which is slide number 2. Then you knock down your primary. And when you knock down your primary, it's going to fail over to the backup that's now up and running on the new version. And then you can bring up what used to be your primary. And you've now finished a rolling upgrade. This does have the interesting side effect that you've actually switched the primary and backup where they're continuously running. But since these are perfect mirrors of each other, that's not a concern. We're also able to provide a multi-tenant solution. We provide isolation. We can do this on pretty much every metric out there. We can provide this on isolations on a user basis. We can also provide isolation all the way down to messaging partition basis, and we can provide isolation based off of different multicast basis, and et cetera, so on and so forth. One of the big consumers of this is that a lot of our clients that are very latency sensitive end up running things in their individual NUMA nodes. That means, for example, that we're accessing cores 1 through 5 for an order processing engine, where cores 7 through 11 are working with a location processing engine, and that you're not swapping memory, that you're not swapping, that you're not using the other person's resources, and you're guaranteeing the maximum amount of speed. And as you can see, we've isolated these two environments based off of in this particular example, based off of the channel descriptor that we've built. Now, one of the difficult, and I mentioned this before, saying we're going to bring it up later, and so we're at later, I guess, is one of the difficulties of writing micro-based services is managing the ecosystem, is managing individual microservices. When you bring up one microservices, that's pretty easy to manage, except that it's a primary and backup. So if you want to do an upgrade, you got to log on to 2 machines. And that means if you want to do, if you have 2 microservices, it's got 4 machines, 3 microservices, 6 machines, so on and so forth. We have clients out there that have 50 microservices or 300 and 400 microservices. I mean, you'll be upgrading for a month. This is that's not a viable option. So we provide you the ability we provide you with a tool called Lumino that does these upgrades for you. Not only that, if you want to track messages, how these messages are flowing throughout your entire system, right? You will end up having to log in to 5 or 6 different, in the event that you're only dealing with 5 or 6 different microservices, you're gonna have to log into 5 or 6 different Unix machines trying to figure out where that message was processed. And not only, you're gonna have a very, very hard time tracking that particular message because there's clock skew. So unless you've got GPS-enabled systems hooked up to each other, and those are only down to the millisecond, by the way, that becomes a difficulty. And we provide you some insight into that. In addition to managing your ecosystem and letting you run execution commands and look at different dashboards, we give you a detailed view into not only what is going on that particular server, right? But even a detailed view into going on in what particular system. How many messages have you received? How many messages have you sent? How long has it take between a receipt of a message and the processing of a message? I haven't looked in about a month. Last I looked, we had 75 different metrics that we're tracking individually per service. So that's quite a few. We can also, so again, you are able to correlate number of messages, number of and heap and memory usage, and you're going to be able to correlate these things very, very easily using a drill down for your app. Something else is that we provide you the ability of building out customized dashboards for those clients that do have 300 microservices or 50 microservices. You're able to see these microservices running in any of the particular ways that you want to do it. Another of the difficulty that you end up having when building microservices is the fact that everybody will do, and again, you build the service that does one good thing and one thing and it does it well. So you're going to do, a checking account, for example. You can add and you can deposit and credit, or deposit, add and remove from your checking account. But that also means that you need some administrative stuff. So does that mean that I have to build out a separate communication channel and I've got to define different message states and I've got to define it, like, oh, so it's not just doing one thing anymore, it's doing multiple things, because those administrative stuff such as adding users, removing users, seeding your account, pausing your account, freezing your account, doing all of that stuff, you need to build that in. Now we give you the ability to add those administrative messages through what we call command and control, right? You provide a command annotation, and then that command is going to be exposed through our Lumino dashboard for your operators to be able to use. So it becomes very, very easy and very, very quick for you to expose those command and control capabilities instead of having to build out a separate new client. Okay, as promised, we talked a little bit about the IoT, and we talked a little bit about the X platform. And if you haven't noticed, I've sort of bled in why the X platform is such a good use case for the IoT. So we're getting to our summary page, and basically let's talk about the parts that it does solve relatively well. Well, the compatibility and longevity, that's built into how we handle our message structures, right? Intelligent analysis and transaction, that's built in by design because you're keeping all of your states in memory and you're able to process those analysis and take appropriate action. Scalability and latency, again, that's I feel I spent a good amount of time talking about that. And security and privacy, again, that's one of those really long conversations, but I just gave you a quick preview of that particular slide. Now, there's a few things that I didn't add on there, and that's horizontal evolution. We don't help people to come up with new technologies. We will handle any messages coming out of those technologies, and we're not helping define standards, right? That's for like the Fog Computing Consortium and things of the sort. We will be able to consume any of the messages that you provide and apply them to your system. but we're not going to help define those standards. I think that's really it. So, I mean, if you guys want to email us with private questions, please feel free. This is my contact information, Kevin at Neve Research, or our general contact email. So that's contact at Neve Research. We've also got some great open free demos on NVX apps. You're able to download them. We've got a quick getting started doc that should get you up and running. I think it's within 30 minutes, 45 minutes. And we got a couple of YouTube stuff, YouTube tutorials on how to use the system. One of the links is there, and you can also look under Kev Goal 0. So, does anybody have any questions?
So, Kevin, it looks like we have a couple of questions coming in, and the very first one is regarding the product that you were showing and working with. Basically, the question is, where do you get that product, and is it open source?
All right, that's a great question. So the X platform is, yes, it's a private source, but it's free to use, and we've got 5 different products total. Lumino's one. We have 5 different offerings. If you just go to our website under the products category, you can download and use them as you see fit.
Awesome. And it looks like we have another question that's coming in that's, sorry, I'm going to try to put these two together, but the question is it possible to use other products, or do you have to use the entire X platform that you were showing?
Other products like Kafka, for example, or a messaging platform, or are we talking about like databases, right? So,
yep.
Absolutely.
It looks like one of them mentions Kafka, so yes.
Okay, so absolutely. From a messaging platform, yes, we did not write another messaging platform. We sit on top of asynchronous guaranteed messaging systems, and these are all the platforms and systems that you know and love, like Kafka, Solus, Tibco, any of the MQs like ActiveMQ. We sit on top of that, so absolutely. Now, connectivity to databases or other of the traditional stuff, like I mentioned, we provide full connectivity through, we have 2 different processing kinds, stuff that one is a gateway and one is a processor. So you can get access to all of your traditional architectures via these gateway processes. So the answer to both questions is yes. I think I answered it.
Okay, great. And that looks like pretty much all of the questions that we have. And also, we do want to thank everyone for your time today. There will be a copy of the recording available. Typically, the GoToWebinar service will send you a link to that. We'll also make Kevin's handout available through that site as well. So if you have any questions, of course, you're welcome. Further questions, you're welcome to email. Otherwise, we appreciate your time today, and we'll talk to you soon.